Hello dear friends and welcome to the first in a series of tutorials regarding basic electronics. For this tutorial we are going to use TinkedCad.com, which has a really interesting online simulation tool, and we're going to build some basic circuits. Um, First of all, we'll try to build a lead balancing circuit, a push button with a DC motor, and a photoresistor that controls an LED. So let's get into it. First, we have to create a circuit, and then, of course, we have to select the components. So here you can see a list of components that are available. These are the basic components. I usually go with all components. There are some resistors, capacitors, inductors, some push buttons, potentiometers. These are quite a lot of components here, but we will start first with some of the basic parts that we will need for the first circuit, which will be a lead balancer. First of all, we need a power supply. So then we are going to place this power supply here. It's a power supply which has a 5-volt output and a 5 amp current through it at the moment. We will first increase the voltage to 10 volts for the power supply, and uh, this is our main power supply. When we push the start simulation, we can see that it's outputting 10 volts and 0 amps. So the first target is to get our um, lead balancing circuit underway. So first of all, we will need some canvas to build the circuit on. So this canvas in this case is a breadboard. The breadboard is an engineer's best toy, let's say, because it's an environment that you can use to quick prototype a lot of your projects. The main advantage for a breadboard is that all the pins here are interconnected. So if I connect one of these pins to a supply, then this is connected, all these pins are connected to the supply. Same here, if I connect one of these pins to a terminal or voltage level, all the other 5 pins are connected to the same voltage level. As a rule of thumb, I usually use the top side for the supply voltage and the bottom side for the ground reference. So then I will connect this. So now our breadboard is connected. First, let's turn an LED on. So for this, we will use a LED that we will place. An LED is a electronic component that has the capability to emit light when a current flows from the anode to the cathode. This means that we have to connect the circuit here to the power supply and see what happens to the LED. Okay, just that we limit, because we are using a 10-volt power supply, just to limit the power that the LED will consume. We're going to place a resistor here. This resistor has the role of limiting the current so that we don't break the LED with the high voltage that we're using here. This has a 1 kilo ohm resistance, and we just simply have to connect the plus and minus values for the circuit and the minus. So this means that when we are going to turn the circuit on, the current will start flowing from the positive side through this 1 kilo ohm resistor, through the anode to the cathode, and then back through the ground circuit, because these are all interconnected and these one is the same. Okay, let's see if this turns on. The LED is clearly turned on and it's currently operating at 8.04 milliamps. Um, just a rule of thumb, usually these small type of LEDs don't usually take more than um, 30 milliamps. So always it's good to use a limiting resistor, whatever you are using here. Okay, good. So we have our first component supplied. We can stop the simulation. For doing a LED balancing circuit, we are going to use, besides this resistor, which is just for limiting current, which we can rotate and we can place here, we are going to use also a potentiometer. So what is a potentiometer? This is a electronic circuit which is equivalent to the following circuit. So if I had two resistors here, between these two terminals, here and here, this is the, let's say, the internal structure of a potentiometer. So this wiper pin is the center pin, and this moves from one side to another, increasing one of the two resistors here. So this means that if this resistor goes up in value, this resistor will go down in value. So there is always a risk of burning the LED. This is why we will need this current limiting resistor here. Good. So we have placed the potentiometer here, and then we are going to connect it to our circuit. So I will draw this here. This is connected here, and this should be connected here. Okay, this means that the current will flow through the VDD, the supply values, through this resistor to this point, and here. I'm going to move the potentiometer here, and now this is the supply value. This is the center value. This means that I have to connect one of the terminals. So this one, it's the cathode, but I need to connect the anode. So this means that I have to mirror this component and then this connect this to ground. So let's see how our circuit is looking right now. So you can see that the current has decreased significantly here because this is always also flowing through this potentiometer, not only the resistor that is limiting the current. So this means that this potentiometer, oh, this is really big. So 250 kilo ohms is quite a big um, potentiometer for a small circuit. Let's go with 1 kilo. So we have 1 kilo here and another kilo in series through the potentiometer. Okay, so we are back to 4 milliamps. Okay, if we turn the knob, we can see that the current is increasing to the maximum of 8.03, which was the current when we had a direct connection between this point and the anode of the LED. This means that the potentiometer is in short here. And in order to, the 8.03 milliamps is not the maximum current that this LED can drive. If, for example, we decrease this resistance, the current limiting resistance, to about 100 ohms, you can see here that the value has increased to 74 milliamps here. This is quite high, so then we would have to increase this resistance even more because 75 milliamps will burn this LED here. So then I can stop the simulation and start it again. Now we are at 50 milliamps. This means I have to decrease this even more, so I can put about 300 ohm. This is 26 milliamps, is quite good current going through this LED. Okay, and this, if we are going to do a LED balancing, we need another um, a LED to help us do the balancing here. So I'm going to place another LED, mirror it, and connect it to the other terminal of the potentiometer. Okay, and click the start simulation. So basically the circuit acts as a load balancer when one LED, and here you can see, 25.8, it's still too much. You get an error for this. This means that the LED will be most likely broken. Because of this, we have to increase even more the resistance here. So I'm going to put 400, and with 400 we are 19.8, so we are quite well. And then we are switching to the other side, and on the other side we have good um, good balancing. If we want to switch this LED, for this LED to be a bit brighter than the other one, we can also yeah, we can increase the value here for the potentiometer to about 5 kilo ohms, and this means that, yeah, this one would be a bit less brighter because it's passing through a bigger resistance now. Okay, this would be the first circuit. What is quite interesting to note for the circuit is yeah, the use of a potentiometer. It is a good circuit to use, but they are quite noisy if you're going to use them on any input. They're going to be quite noisy component, and they also have quite high tolerance, so it's never a precise value for this. It's always varying. Also, what we can do is we can measure the difference of currents flowing through the power supply, through the limiting resistance, the potentiometers, and the LED. So for this, I am going to use one of the measuring equipment, which is a multimeter. So this multimeter at the moment measures voltage, but I can set it to measure current. One very important thing to note is that when you are measuring current, always it has to be in series with the circuit, with the current flow. So if the current flow is flowing through this resistor, we would have the potentiometer, the LED would have to replace this line here with a line from the multimeter. This will go here. Okay, and then the other line from the negative would be going on the other side of the ground lane. Okay, this is one multimeter, and then we would need another one for the other LED. So the same process, we replace this line, we take the current, we take the line connected to the cathode, and then we connect it to ground so that we can see the difference here. Let me just fine tune this so that it is quite simple to see. Now we're going to run the simulation, and we can see on the center the two resistors between the wiper and the terminal 2 and wiper and terminal 1, or the pin 1, are identical. As we switch to one side or the other, the current on one branch grows while the current on the other branch dies. So it is quite simple to understand. Okay, this would be the first circuit. The second circuit is going to be something quite similar. So here we have a button. This is a very simple button. You can find it in most electronic stores. But it's the purpose for this button is that when you connect one terminal, so when you push the button, the terminal 2B and terminal 1B are short circuit, and both, so all the terminals are short circuited together. This means that we would have to take the supply line, put it to one terminal, and when I press here, this would when you press the button, this would connect this terminal to the other terminal and this one, and then push the motor. For this, we're going to use a DC motor, simple DC motor. Um, for this motor, let me switch it a bit. Yeah, okay. Simple DC motor. Okay. And connect it to the circuit here. And from this, we would have to drive it to ground so that it's has a, oh, there's a big a quite problem because these two pins are in short circuit, so the power supply would go would blow up. So let me switch it a bit, that I connect it this way, and then we go in the following way. From this terminal we can go here to the positive side, because these all five were connected together, so this would mean that the power supply would be shorted to ground, and this pin we will take it and connect it to the ground and reference of the circuit. Okay, now when we start the simulation, we see 0 RPM. This is not showing quite well as I wanted, so let me switch this. Okay, 0 RPM, and then when we press the button, you can see that it is switching, it is working at about 1000 RPMs. Also, one additional thing we can see is when we're switching this on, you can see a significant increase in current. So we have 19.8 milliamps. When we're switching this one on, you have 180 milliamps. That the difference in 160 milliamps is driven by the motor. Okay. So mainly for the circuit, when you press the button, you have a short between all four pins, and the pins on this terminal here, maybe I can move this a bit here, would be better, that that is much clearer to see. So I'm going to take from this terminal connected here, and from this terminal connected to ground. So the idea is that when I push this, you can see the motor spinning. It's a simple DC motor. It's a brushed motor, so this means that you have only two terminals, and it's a brush, an internal brush that is switching between the windings of the motor. And here the push button has the two terminals here, which are on the same side, are different. So if you have a pin on this side with a pin on this side, this means that they are different. So when you are pressing the button, you are shorting these two pins here. So this is just to take into consideration. Okay, and the last and final circuit is a simple photoresistor circuit. This was one of my first circuits that I built. So it's a fine, simple circuit where you take a potentiometer. So this a photodiode, a photoresistor. So what does this mean? The photoresistor is a resistor that varies its value with different values for light. So I will take an LED, connect the anode to the LED. Okay, then connect the cathode to the ground. And now when I start the simulation, Okay, the LED is a bit bright. There's not that much dimming, but if I change the light source here and I move it to more light source, you can see it has a much better light into it. And then you can also see the value for this resistance. So we are going here, high resistance 19.8 milliamps. So as it was with only these two um, resistors, these two diodes here, and then as we increase this, you can see that it's another 15 milliamps going through this LED here. Okay. What we can also do, and this would be quite interesting, um, for a photoresistor, I'm going just to place one over here. I am going to use a multimeter to measure the value. So the value for this component is going to vary. I'm going to connect this here. It doesn't let me. Just going to place this here. Maybe clean this up a bit. Okay. So this is the negative terminal and then the positive terminal of the multimeter. It doesn't matter in this case because they're resistors. It doesn't matter if you are connecting them this way or the other way around. It's the same value you will read. Okay, and then we're going to go to resistance. Now, when we're going to start the simulation, you can see that the photoresistor has 180 kilo ohms. Once we increase the lighting of it drops to about couple of hundred ohms here, with 506 ohms being the smallest value that you will see. Okay. That being said, this is a rough, let's say, introduction to electronics. Um, there are many more other topics that would make a lot of sense to discuss in future videos. Please leave a comment and subscribe if you find this content interesting. And yeah, wish everybody a great day. Thank you.